So first problem is trig, using trig. It says find the exact values of 6 trigonometric function in given angle, and do not use a calculator. Well, calculator is not allowed. So angle that was given to me, number one, angle that is given to me is 13 pi over 6. But for you, it might be different angle because my MATLAB randomly choose different numbers. Okay, but again, the type of problem will be same. Okay, so keep that in mind. So here we definitely have to remember the unit circle. So make sure you know the unit circle, the values from unit circle, or how to construct one. Okay. So A, well, first part will be sine of 13 pi over 6 is half from unit circle. And cosine of 13 pi over 6 is square 3 over 2. And tangent of 13 pi over 6. Remember, tangent, the output is a slope, changing y over changing x. But how do you find changing y over changing x on unit circle? We can use sine and cosine. So this is the same as sine of 13 pi over 6 over cosine of 13 pi over 6, which we already found on the top. So it'll be half over square 3 over 2. This will give us 1 over square root of 3, and we can rationalize by multiplying square root of 3, which gives us square root of 3 over 3. Okay. So then we find cosecant, secant, and cotangent. So for cosecant, this is same as 1 over sine of 13 pi over 6, which means we can actually just write the reciprocal of this, which is just 2. And for for secant, it will be reciprocal of cosine value, cosine of that angle measure. Which would be 2 over square root of 3, right, looking at this. But then again, we don't usually want irrational number in the denominator. So we're going to rationalize it by multiplying 1, which is square root of 3 over square root of 3 is multiplying 1. So it's not changing the quantity, but we're just changing how it looks. Okay. Then cotangent, as you can see, cotangent will be reciprocal of this, 3 over square root of 3. Rationalize 3 over square root of 3 over 3. Right? Which we can simplify to square root of 3. So that's number 1. So number 1, if you struggle with this material, make sure to review Module 2. This is from Module 2. Introduction to Trigonometry. Okay. Okay. Number 2 is also from trig section. Let me keep it consistent. Use same color for numbering. Number 2. Okay. Number 2, it says find the exact value of each of the remaining trig function of theta. So here, for my problem, it tells that sine theta equals 24 over 25. And it tells me that theta is in quadrant 2. So that means my angle measure is somewhere here. Here's theta. but it tells us that sine is 24 over 25. So let's label this length. So what does sine function mean? It measures vertical distance from the horizontal diameter. So it measures this distance from horizontal diameter, which is this right here, right? It measures this distance in radius length. So that means we divide by the radius length. So if this length is 24, we divide by 25. This is 25. Okay. Okay. And since this is a right triangle, we can find this length using Pythagorean theorem. So 25 square equals 24 square plus, let's call it x squared for now. Okay. So then we can solve for this, right? This is 625. I'm going to subtract 24 squared both sides, which is 576 equals x squared. Okay. And 625 minus 576 gives us 49. So 49 equals x squared. So then what is x? X could be either -7 or +7. So we have to decide which one it is. Okay. So that's where this idea of quadrant becomes important. Because in second quadrant, the cosine value, which measures the horizontal distance from vertical diameter, so it measures this distance right here, is negative. So this length should be negative. And also, if you just think about x and y coordinate, the x value is negative here, right? On second quadrant. That's why it's also negative. Okay, so now using this diagram, so make sure you draw a correct diagram first. Then we just find cosine, tangent, cotangent, all those values. So cosine theta is measuring horizontal distance measured in radius length. So we do -7 divided by radius, 25. Tangent is slope of this terminal right here, slope of this, which is changing y over changing x. So it'll be -24 over 7. Okay. And cotangent is reciprocal of that. Okay. And secant is reciprocal of this, right? Secant theta is -25 over 7. And lastly, cosecant is reciprocal of cosine. So cosecant is 25 over 24. Okay. So this is also Module 2 material. Okay. So if you struggle, make sure you review the videos, homework problems, lab problems from Module 2. Okay, so let's look at number 3. Number 3 says find the difference quotient of f, that is find f of x plus h minus f of x over h for the following function. So function I have is f of x equals x squared minus 6x plus 4. And this is difference quotient. So remember, difference quotient represents average rate of change between 2 points. So in this case, average change between x and x plus h. Okay. So let's find this. First, find x plus h first. So we have x squared plus 2xh plus h squared minus 6x minus 6h plus 4. then we can leave it like this for now. So this part will essentially go to right here, right? So let's rewrite everything. Well, f of x is already written here, right? So we already have f of x, already have x plus f of x plus h. So let's combine all those together. So we have x squared plus 2xh plus h squared minus 6x minus 6h plus 4 minus f of x. So make sure to keep parentheses because we need to distribute a negative sign. Entire thing over h. So here we have to distribute a negative sign. So we get, well, let me actually just rewrite it there. I'm going to erase it and rewrite it. So distribute negative sign. Then I get minus x squared plus 6x minus 4. So minus x squared plus 6x minus 4. So then we collect like term, cancel things out. So x squared cancels out x squared. Positive, negative 6x, positive 6x cancels out. Positive 4, negative 4 cancels out. So we have left with 2x plus h squared, and minus 6h over h. So once we simplify, we have 2xh plus h squared minus 6h over h. Okay. So then we can simplify this furthermore. Since this h is a common denominator, we can think as, well, let's separate all the three terms into three separate fractions. So that's one way to think about it. Then this h is cancelled out with 2x, 1h cancels out, plus h minus 6. So this is the difference quotient of this function. And again, this represents average rate of change. So this is also average rate of change function. Okay, so this idea we looked at actually first week, module 1, but we looked at more meaning of average rate of change in module 4. Okay, so make sure if you struggle with this idea, make sure review module 4. Okay, and it's also important to know the meaning of average rate of change. Okay, and difference quotient gives us average rate of change. Okay, so let's look at number 4. Number 4 says graph the function y equals 7 cosine x. Show that at least 2 cycles, use a graph to determine domain range of the function. Okay. So let's try to graph this. Okay, so first of all, what is the period here? The period is 2 pi. Right? Nothing has changed for regular cosine x, right? So we have 0 to 2 pi. Here's pi over 2, 3 pi over 2. Okay. And we know that before any transformation, cosine 0 is 1. But because we multiply 7, cosine 0 will be 7 in this case. So 7, so amplitude is 7, right? So we'll go as high as 7, we'll go as low as negative 7. Okay. So then let's plot some points. So here, cosine 0, 7 cosine, or 0 of 7 cosine x will be cosine 0 is 1, so 7 times 1 gives us 7. Okay. And it follows this pattern, touches here, 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 like that. Right? And you have this curvature, right, like this. Again, these are not straight line, like this. Okay. And yeah, since 2 period, we'll just do another one, like this. Okay, so this is 7 cosine x. So only transformation that applied here is amplitude. We multiply by positive 7. So what is a domain? Domain is negative infinity to positive infinity. Because for trig function, unless again domain is specifically restricted, we can input any angle as an input. And what's the range? Range here is the y value output. So in this case, it will be negative 7 to positive 7, because graph will go as low as negative 7 as an output, and the biggest value can have is positive 7. Okay. So this is graph of trig function. This is from module. If you need more practice on these and review this idea, this is from module 3b, trig function, graph of trig functions. Okay. So now let's look at number 5. Number 5 says establish the identity. So I have 1 minus cosine squared theta over 1 plus sine theta equals sine theta. Okay. So first it says simplify the numerator of the fraction from left side by applying appropriate Pythagorean theorem identity. Okay. Okay. So how do we do this? So here you have to remember all the Pythagorean trig identity. Okay, so that's very important. So she says the problem says simplify the numerator. So that means numerator. So we have to remember this identity where cosine squared theta plus sine squared theta equals 1. So then we know that cosine squared equals 1 minus sine squared theta. So for the first step, all we're doing is replacing cosine squared 1 minus sine squared. So 1 minus like this. Okay, it says do not factor, so leave it as it is. Now for the second step, it says factor the numerator of the fraction from the previous step. So we want to factor this. Okay. So here we have to use, let me write it on the right side. This is form of a squared minus b squared, which is same thing as a plus b, a minus b. So here a squared is 1, b squared is sine squared theta. So if I were to replace that on the next line, we have 1 minus 1 plus sine theta, 1 minus sine theta, over 1 plus sine theta. Now, we simplify furthermore. We see that 1 plus sine theta over 1 plus sine theta cancels out. Cancellation property. Okay. So then what do we have left with? We have 1 minus, parenthesis 1 minus sine theta. Distribute the negative sign. I have 1 minus 1 plus sine theta. These cancel out, so we're left with sine theta, just like here on the right side. So last part is multiple choice. It says the expression from the previous step simplifies sine theta using what? It's cancellation property and simplifying further. That's what we did here. Okay. So for these, this is from, again, I'm giving you reference point where you need to go back and review for the lesson videos or the homework or lab problems, so you know where to go back if you struggle with these ideas. This is from module 6a. Okay. This type of problem is from module 6a, trigonometric identities. Okay, so let's look at number 6. Number 6 says solve the equation at the interval. For my problem says I have 2 sine theta plus 4 equals 3, and theta is between this right here. So we're solving for trig function, so we want to isolate the trig expression by one side if possible. So first, let's subtract 4 both sides. Then we get -1. Then what we have is sine theta equals -half. Now, what we're doing is we're finding angles between, as given here, 0 and 2 pi, such that sine of that angle gives us -half. So essentially 0 to 2 pi is from unit circle. Okay. Again, another problem where you must know unit circle. So the solution said from the unit circle is 7 pi over 6, comma 11 pi over 6. Okay. So that's it. And this problem is from, well, these concepts are from module 6b. Okay. So number 7. Number 7. Follow the steps for graphing a rational function. To graph the function, and what I have is Rx equals x plus 2 over x plus 7. Okay. And it says, if needed, first write the given function as a single rational expression. Then factor the numerator and the denominator. Select the correct choice below, and if necessary, fill the answer box complete choice. So the first part is factoring, but here is already factored. Right? So this cannot be factored any further. Okay, this is the first part. And his second question is, what is the domain? What is the domain? Right? So domain, we have to find domain before we cancel anything out. Even if you can cancel something numerator, denominator, we do not cancel anything out. So here, domain, we cannot have, what values can we not have in the denominator? X cannot equal to 0 and -7. Again, this is using separate notation. And I know a problem doesn't ask interval notation, but if you were to write an interval notation, it would be -infinity to -7, -7 to 0, 0 to positive infinity. And third step, as write the Rx in the lowest terms. Select the correct choice below, if necessary. Fill in the blank. But Rx, this is already in lowest term. Okay, so just select Rx as in lowest term. We don't need to do anything else. Okay. Now let's find the x-intercept. The next part as x-intercept. In order to find x-intercept, what we have to do is we have to set the entire function to 0. Okay, so we set x plus 2 over x times x plus 7 equals 0. But whatever denominator is, it cannot ever make it 0. So only thing we have to worry about here is numerator, because only numerator can result the output value, output quantity becoming a 0. So when x is negative 2, we can see that it will be 0 over a number, which is 0. So x equals 2. Sorry, x equals negative 2, right? So x-intercept will be negative 2 comma 0. And in terms of the MATLAB, the graph has x-intercept negative 2. Okay, so for now. And let's try to find y-intercept also. Okay. So in terms of y-intercept, what we do is we have to plug when x equals 0 here. But 0 is not in domain, right, as we saw here. That means this automatically does not have y-intercept, so no y-intercept. Okay. Okay. Now, next part says determine the behavior of the graph of R at any x-intercept. Select the correct choice below if necessary. Fill in the answer boxes and complete your choice. Okay. Okay. So here we have to remember what we learned before from polynomial graphing. So again, remember the rational function is just polynomial over another polynomial function. Okay, so will the function cross? Look at this. So at x-intercept, when x equals negative 2, function Rx will cross x equals negative 2. So cross as in if there's x equals, on the graph here's negative 2, function will cross. Not touch, it will cross. Okay, and how do we know that? Well, look at this. This is odd degree, right? When it's odd degree, it crosses. So that's how we know. Okay. Next part is asking us determine the vertical asymptote. Okay. Determine the vertical asymptote. If one exists, select the correct choice below and again fill in the blank. Okay. So vertical asymptote, we have two of them, x equals 0 and x equals negative 7 from here. Right? Again, if this is simplifiable, we do not look at, we have to look at the simplified version. But since it's already simplified further away, we just look at we look at the denominator and what will make 0 in denominator. So here this would be the leftmost, This is the rightmost. Okay, so that's how you type your answer. Okay, now the next part is asking, let me make sure. Okay, determine the behavior of the graph on the either side of any vertical asymptotes if one exists. Select the correct choice in below, right, and fill in the blank. So here, what we're doing is, here is x equals 0, so let me, and -7. So let me use different colors. So here are the vertical asymptotes. Vertical asymptotes. This one and this one. Okay. So what's happening here is we know that for vertical asymptote, as the input quantity approaches vertical asymptote from left to right, either it will go positive infinity or negative infinity, right? So keep that in mind, right? So the way I recommend you do this problem is just try to graph it, okay? Because once you try to graph it, it will give us a trend. If graph, okay, does it approach positive here or negative infinity like this or this? It will give us an idea once we sketch. Okay, so let's try to sketch these. Let me try some points first. Hold on, my pen's not listening to me. Hold on. Okay, finally. Sorry about that. Okay. Okay, so let me rewrite Rx. Rx is x plus 2 over x times x plus 7. Right? So let's just plug some points. Use different color. Let's see what we do, what we get when we get -8. So r of -8 will give us -6 over -8 times -1, which is -6 over +8, which is -3/4. So when -8, it was -3/4, so it is somewhere here. Let's say approximately. Okay. Let's try -9. Okay. Or -9 give us -7 over -9 times, what is it? -2. -7 over 18. Okay. Which is bigger or better than -8? What at -8, so it'll be somewhere here. So the graph will shape something like this. Okay. It goes towards -infinity. So we established one side. Now let's look at right side of -7. So we're going to do that. We're going to plug maybe -6. So then r of -6 gives me -4 over -6 times 1, which is -4 over -6, which is +4 over 6, which is 2/3. So if this is 1, 2 over 3 is, let's say, just somewhere here. Okay. Okay, so then let's also try negative, no, negative 4. Negative 4 plus 2 gives me negative 2 over negative 4 times 3. Gives us negative 2 over negative 12, which is 1 over 6, which is smaller than 2 over 3, somewhere here. So at least we know for here we go this direction here. Right? We also established earlier that at negative 2 it will cross. So it will also cross and it will go towards negative infinity and left side of 1. Oh, sorry, 0. Left side of x equals 0. Okay. Okay, so then let's look at this side. When is 1? When r equals 1, we get 3 over 1 times 8. 3 over 8. Little less than half right here. When r is 2, we get 4 over 2 times 9, which is 4 over 18, 2 over 9. 2 over 9 is smaller than, okay, something like this. So at least for trend, we know they will go positive infinity like this here. Okay, so now that we have like basic idea, right, of the behavior around the vertical asymptote, we can conclude that that in terms of the multiple choice is given in the problem, it'll be it approaches infinity on the one side of the asymptote and negative on the other side, right? So let me tell you the letter. The part C. So C is the answer for this problem. To determine the behavior of the graph of either side of the any vertical asymptote, it will be the C. It approaches infinity on the one side of the asymptote at x equals 0, negative 7, and negative infinity on the other. So what is that saying? This is saying that for look at for negative 7, on the left side, on the one side of negative 7 is approaching negative infinity. On the other side of negative 7 is approaching positive infinity. When x for the vertical asymptote of 0, on the other side approaching negative infinity, other side approaching positive infinity. So that's why the answer is C. Okay. Okay. Now is asking to find horizontal asymptote if it exists. Horizontal asymptote. So here we have to see the degree of top is smaller than bottom. So degree of bottom is 2, because if we were to multiply this out, we'll get x squared term, where degree on the top is 1. So bottom degree is bigger. In that case, our horizontal asymptote is y equals 0. Okay. And this does not have any oblique asymptote, because in order to have oblique asymptote, the top degree has to be greater than exactly 1 compared to bottom degree. Okay. So horizontal asymptote of y equals 0. And the next part says determine the points, if any, at which the graph of R intersects the horizontal or oblique asymptote, right? So this is asking when does this function equal 0, right? When does it cross horizontal asymptote? And we already established that, but let's just go over it one more time. Equals 0. Well, again, we saw that x equals -2 will cross 0. Okay. So the graph R intersects horizontal asymptote at -2, 0. Okay. So last part, it says use the graphing utility to and the result from the previous steps to graph R. Okay, and choose the correct answer below. So here, yeah, so essentially what we did here, right here, but we do have to add the horizontal asymptote, right? So let me actually highlight the correct graphing portion. So it would be like here, because horizontal asymptote, this right here, and this right here. And it crosses horizontal asymptote. And it is okay to cross horizontal asymptote or oblique. It is just not possible to cross vertical asymptote. Okay, so make sure you remember that. Okay, so this is problem 7. And this is from, or these concepts are covered in module 7, rational functions. Okay, so let's look at number 8. Number 8 says solve the log equation, which is what I have is log 5 for x minus 3 equals 3. So when we solve log, right, there are a few types, but this is one type where we have only one log expression and number on the other side. So try to rewrite in exponential form. So that means that 5 is base to the third power gives me 4x minus 3. 5 to the third power is 125 equals 4x minus 3. 128 equals 4x. X equals 128 over 4, which is 32. So 32 is a possible solution. We always have to make sure we can plug 32 in here, and inside will be still positive. And it is, since 32 times 4 will give a bigger number than 3. So this is a solution. Okay, so make sure to check your solution for log equations. Okay, and this is from, this is from module 9, solving log equations. Okay, so number 9. Solve the given systems of equations. If the system has no solution, say this is inconsistent. So equation what I have is, so for when the problem doesn't specify what method to use, you can use any of the methods that we discussed. So either matrix or regular elimination. So here I'm actually going to use elimination. Okay, so not matrix, but you're also welcome to use a matrix. Either one's fine. And either if done correctly, both should, you know, give a same answer, of course. So let's label as first, second, and third equation. So for first and second equation, I'm going to multiply -2 to first equation to get -2x plus 6y minus 8z equals -24. Oops, I forgot to write one thing. I'm going to eliminate x. Then second equation, I have 2x plus y plus z equals -4. So let's add. I get 7y minus 7z equals -28. So this will be our fourth equation for now. And I'm going to add 2 and 3 to eliminate to get fifth equation. So add 4y minus 4z equals -12. Fifth equation. Okay. So then now, using fourth and fifth equation, I'm going to eliminate one variable. Okay. So here both are equally equal level of difficulty or equal level of time consuming. So I'm just going to select y. So eliminate y. So let me multiply -4 to fourth equation. -28y plus 28y equals 28 times 4, 32, 112. So -4 times -28 gives me positive 112. For fifth equation, I'm going to multiply 7. Gives me 28y. Let me see. Oops. Made an error here. This is z. Okay. y and minus 28z equals -12 times 7 gives me 90. This is at 84. 14. Yep, 84. -84. Okay, so let's add across. Let me make sure I didn't make any error. Let me see. Give me 1 second. Ooh, I see my error. When I add these, I should get 2z, which will change this to, let's see, 7 times -2 gives me 14z. Okay, so then when we add across now, we get 14z equals, what is that? 80, 28? Yep, 28. So then we know that z equals 2. Okay, so we can plug z equals 2 to either 4 or 5 to get y. So let's just plug it here. 4y minus 2 times 2 gives me 4 equals -12. 4y equals, what is that? -8. Y equals -2. So then I can plug both of them to any of these three equations. So let me plug it here to solve for x. So x minus 3 times -2 plus 4 times 2 equals 12. X plus 6 plus 8 equals 12. X plus 14 equals 12. Subtract 14 both sides. I get x equals -2. So answer is -2, comma, -2, comma 2. Okay. Well, in MATLAB, it asks you to type one at a time. X equals -2, y equals -2, z equals 2. Okay, so this is from what module? Was it module 10? Okay, so let's look at problem 10. Write the partial fraction decomposition of given rational expression. So what I have is this. So first we need to factor it. It'll be -3 minus 9. Okay. Oops, x minus 9. X minus 9. So we know that then x minus 3, x minus 9 equals to a over x minus 3 plus b over x minus 9. So multiply common denominator both sides. We'll multiply this both sides. Then we get x equals a times x minus 9 plus b times x minus 3. Then we get x equals ax minus 9a plus bx minus 3b. So here it tells us that, well, if I do ax plus bx, it should give me 1x. So that tells us that a plus b must equal 1. On the other hand, -9a minus 3b should give us 0 since there's no coefficient term in this side. So that tells us -9a minus 3b should give us 0. So here we're doing systems of linear equation. We have two equation, two unknown, so we can use either matrix or regular elimination. Okay, so let's do regular elimination where I'm going to multiply 9, the first equation. Oops, don't need a line there. -9a minus 3b equals 0. Okay, so let's add. 0 here, 6b equals 9. So this tells us that b equals 9 over 6, which is 3 over 2. And what is a? Well, using this equation, a plus 3 over 2 should give me 1. A is negative half. So final answer, okay, so when we type it, final answer should be, whoops, using this right here. Final answer is a is negative half, so negative half over x minus 3, plus b is 3 over 2 over x minus 9. So this is the final answer. And this is from Module 10. Module 10. Okay, so let's look at 11. For a given function f and g, complete the parts a through h. And for parts a through d, also find the domain. So the function I have is 5x plus 6 and g of x equals 2x minus 3. So here the part A says find the fa plus g, f of x plus g of x. So the part A, add those two. So whereas I am doing this means just add those two functions. So 5x plus 6 plus 2x minus 3 gives me 7x plus 3. That's it. And domain of this function is any real number, right? All real numbers. Okay. In part B, subtract. So when we subtract though, make sure to keep parentheses. So we have 5x plus 6 minus 2x minus 3. 5x plus 6 minus 2x plus 3, which is 3x plus 9. And for this function also, domain is all real number, right? It's just a linear function. And part C is multiplying. Just multiply these two, right? Regular multiplication, where we like do this. Then I get 10x squared minus 15x plus 18x minus 18. Oops, sorry. That's not 18x, 12x. So then we collect like terms, simplify this part, we get 10x minus 3x minus 18. So these are more just algebra review, right? Multiplying things. And domain is any real number as well. This is quadratic polynomial. So now part D asks us to divide. So for dividing, it's just 5x plus 6 over 2x minus 3. But here for domain, we actually have to exclude one number, right? So the domain is x such that x cannot equal to 3 over 2. Because when x is 3 over 2, this function is undefined. Okay. So I'm actually going to skip e through h because those are just plugging numbers. Right? So for e through h, you plug number here. For me, it says plug 4 here, plug 2 here, 3 here, and plug 1 here. Okay. So 11 was more of a review, and this will, I'll say, mostly cover from module 1, because module 1 we discuss domain, module 1. Okay. Then let's look at 12. Says, use the remainder theorem to find the remainder when f of x is divided by x plus 4. Then use a factor theorem to determine whether x plus 4 is a factor of f of x. So f of x that is given to me is this. And divide by x plus 4. So the question is asking what would be the remainder, and it also asks yes or no question of is x plus 4 a factor of this function, right? So here you could do a synthetic division, but the problem specifically says find the remainder theorem. So actually finding the remainder theorem could be faster and more efficient. Okay, so what does that mean? So remainder theorem says that if x plus is a factor, that means when I plug negative 4, because this is form of x minus negative 4, right? This is k from the dividing polynomial section. If it's a factor, that means when I plug negative 4, this should be 0, right? Okay, so we can try this. Again, you're also welcome to synthetic division to see if it's divised or not. Oops, 6th power. So let me rewrite it. So 4 times negative 4 to the 6th power, negative 64, negative 4 to the 4th power, plus negative 4 to 3rd power minus 12. Okay. So if this is 0, if this turns out to 0, we want to simplify this, then we know this is factorable by x plus 4. Okay. So let's see. Okay. Again, although like this higher order multiplication seems might take a while, it still could be faster or more efficient than doing synthetic division to find out. Okay, so 4 times 4, negative 4 to the 6th power is 4096 minus 64. 4 to the 4th power is 256. And 4 to the 3rd power is 64 minus 12. So let's do this right here. This will give, again, this is just regular multiplication, right? Minus 64 times 256 is, oh, actually, let me do that again. Yeah, so 64 times 256. Hold on, let me just make sure. 256 times 64 gives me 4. Oops, 3 here. Okay. Yeah, so 64 times 256 also gives us this. Oops, and I made an error. This should be negative, right? Because negative third power gives us negative 64. Minus 64 minus 12. So these two numbers actually cancel out. So what I've left to will be negative 76. So what this tells us is that when I plug f of negative 4, it was negative 76. Since this is not 0, x plus 4 is not a factor of f of x. Okay, so in just a yes or no question, answer is no. And this also tells us that this is the remainder. And again, make sure to practice synthetic division on your own time as well. But if you do actually do synthetic division, you get negative 76 as remainder. And that's what factor theorem tells us. So this is actually also remainder. So the remainder is negative 76, and no, x plus 4 is not a factor. Not a factor. Okay. And this is from module, what is it? 5, module 5, synthetic division, factor theorem. Okay. Okay. So let's look at 13. Thirteen is very similar to what we did earlier. Graph the rational function. Essentially, what I have is Rx equals 3x plus 3 over 4x plus 16. Okay. So first part, factor. So we can factor this to 3x plus 1, 4x plus 4. And this is the lowest we can simplify into. And domain, we cannot have x such that x equals negative 4 because it will give us 0 in the denominator. Right? And this is a leading lowest term, so you can just select that option. And x and y-intercept, well, x-intercept, we solve this equal to 0. Well, we look at the numerator, will be 0 when x equals negative 1. And y-intercept is when we plug 0 in. Here, we can plug 0 in because 0 is in domain. And when I plug 0 in, I get 3 over 16. So plug 0 here. This is 0, 0. So we have 3 over 16 left. Right? So y equals 3 over 16 is the y-intercept. Yeah, in MyMATLAB, they ask you to type just this number. But when we're graphing, make sure these are coordinate points like this. Okay. And the graph will cross at negative 1. Right? It's just it'll cross x equals negative 1 because 3x plus 1, this is odd integer, right? Well, 1 is implied. So it'll cross. And vertical asymptote, it has one vertical asymptote, which is x equals negative 4. And determine whether the behavior of the graph on either side. Again, those, in order to do that, right, we have to sketch the graph, right? So we have vertical asymptote. We have only one this time. And -4. Okay. And -1, 0 is x-intercept, y-intercept, let's say somewhere here. Okay. So in order to do this, right, we have to plug some points. -5 r of -5 gives me 3 times -4 over 4 times -1 gives me 3. Okay, so my -5, 3 is somewhere here. Okay. Yeah, just for time's sake, again, this is just algebra, right? So just plug some numbers, -6, you get a number somewhere here. So the trend is this. And similarly on the right side, okay, just plug some points. We'll have trend or something like this here. Okay, well, this positive infinity one side and negative infinity the other side. Okay, so the answer will be C. It approaches infinity on the one side, on the asymptote at x equals -4, and negative infinity on the other side. Okay, and let's look for horizontal asymptote. Horizontal asymptote, well, they're same degree, so the coefficient. So y equals 3/4. So if I were to add it to graph, somewhere here is horizontal asymptote. Okay, and there's no oblique asymptote because degree and top are same. Yeah, and graph, there's no point in which the graph intersects at a horizontal or oblique asymptote. Okay. Okay. So for that one, well, we know that horizontal asymptote is this, right? So the question is, let me just bring it here. Would this function ever equal 3/4? Is there x value exists such that this equation equals 3/4? Okay, so yeah, we can try to solve for it and we'll see that there's no answer. So I'm gonna do it here real quick. So we can, what I can do is I can multiply 4/3 both sides to cancel these numbers out. Then I get x plus 1 over 4x, oops, sorry, not 4x. X plus 4 equals 1. So this is saying that x plus 1 equals x plus 4. That is not possible. Oh, it's just not possible. But again, if it's still not, apparent to you, just subtract x both sides. We'll get 0, and right side we get, if I subtract 1 both sides, I get 3, which is never true. That's why there's no x such that will make this equation true. That's why the graph will not intersect or cross horizontal asymptote. And sketch the graph, right? This is the A, which seems like this one, right? Okay, so this, we already did this very similar problem. This is from module 7. Okay, so let's look at 14. For f of x equals 9x plus 4. So for my problem, I have 9x plus 4. G of x equals 4x. Find the following composite function and state the domain of each function. Okay. So this is composite function as we learned in module 1. So f composite g is same as f of g of x. So we have f of 4x because this is g, right? That means we plug 4x instead of x here. So we have 9 times 4x plus 4 gives us 36 plus 4. Right, so I recommend practicing writing all these steps to remove any mistakes, right? And domain is all real number for this function. And g composite f is now g of f of x. So plug f of x here. Well, f of x is 9x plus 4. So plug 9x plus 4 to g function, which is 4 times the input. Input here is 9x plus 4. Distribute 4, we'll get 36x plus 16. And as you can see, domain is still all real numbers. Okay. Now they're asking us to f of f. That means f of x. So then f of 9x plus 4. That means I'm plugging in 9x plus 4 into the function 9x plus 4. So 9x plus 4, I'll plug 9x plus 4 here again. This gives me 81x plus 36 plus 4. Gives me 81x plus 40. Still domain is all real numbers. This is a polynomial, right? Similarly, g composite g, g of x. I'm plugging 4, I'm plugging 4x as input quantity to 4x. So it's 4 times 4x, 16x. Domain, all real numbers. Okay. So this is from module 1. Module 1. Let's look at 15. 15 is very similar. Fine. Well, similarly, I have f of x given as 4x minus 8. G of x given as x over 4 plus 2. Find f of g of x. So f of g of x is the part 1. Is 4. G of x is the input. Minus 8. If I simplify, I get x plus 8 minus 8 equals x. So this is f of g of x. Give any values, x need to be excluded from f of g of x, which means essentially find the domain, right? Here, no value should be excluded because we can plug anything here, right? Find g of f of x. Okay. Which is x over 4 plus 2. G of f of x, 4x minus 8. So this is the input now. So 4x minus 8 over 4 plus 2, which is x minus 2 plus 2, also x. Okay. And no value should be excluded again. Now part C, determine whether function f, g are inverse of each other. And answer is yes. So this is where we have to remember definition of inverse. Inverse function. Two functions are inverse to each other if f of g of x, if I simplify, I get x. And also if I simplify g of f of x, I get x. So both simplify to x and x. So then f and g are inverse to each other. And for inverse function, sometimes we write this notation, right? F inverse. So we can say that F inverse equals, in this case, G of X. Or we can also say G inverse is same as Fx here as well. However we want to name it. So are the functions f and g inverses of each other? Answer is yes, because we simplify both composite to equal x. If one of them is not equal to x, then it's not inverse to each other. This is from module 1. Okay, 16. The given function, which is f of x equals 8 over 3 plus x, is 1 to 1. Find the inverse and check your answer. And find the domain and range of f and f inverse. Okay, so let's find the inverse first. You need to find inverse. Again, only 1 to 1 function has inverses, right? So y equals, write it as y equals 3 plus x first. Then we replace all the y's with x and all the x's with y. So if x equals 8 over 3 plus y, now we want to solve for this y right here. In order to do that, we need to multiply both sides by 3 plus y, like this. So then we get, I'm going to distribute x right here right away. 3x plus xy equals 8, since these two cancel out. Okay, so then here we want to solve for y. We want to, before we isolate y, we need to factor x out here. Well, no, not factor out. We need to subtract 3x both sides. So then xy equals 8 minus 3x. Over 8. Oops, sorry, not 8. Then I'm going to divide by x both sides. Then I get y equals 8 minus 3x over x. For our final answer, we always have to come back to this notation. F inverse of x equals 8 minus 3x over x. This is the inverse function. Okay, so then it asks us to find domain of f and f inverse, right? So let's find domain of function f first. So domain is anything such that x cannot equal negative 3 here, right? Because as we can see, we cannot plug negative 3 here. Okay. And what is there? How about range? Y such that y. Here, we have to think about what number can we not have here as an output. It would be 0. Okay. We cannot have y as equals 0 because 8 divided by any number cannot give us 0 ever. Now for f inverse, though, all we do is just flip the domain range. So this domain will be range for this function. But except that we have to write in y. And this will be the domain. And you know what? When we check it, it will also make sense. We're going to make sure domain means we have to use x and range we use y. So let's look at for m inverse. We cannot have 0 here, right? As it says here. And for output, it's not as intuitive, but we cannot also get negative 3 as an output here. Okay. So that was number 16 from module 1. The concepts are from module 1. Okay, so let's look at 17. Solve the equation 3 over 5 to the x power equals 27 125. So this is exponential equation. When we have exponential equation, if we can, we want to try to have same base. So 27 is same as 3 to the third power. 125 is same as 5 to the third power. And this part we can rewrite as 3 to the x power over 5 to the x power equals 3 to the third, 5 to the third. So here we can see that x has to equal 3. Right? So solution set is 3. This is from module 9. Sorry. Module 9. Okay. Now 18 says change the exponential statement to the equivalent involving logarithm. So I have 4.5 equals a to the x power. In terms of log, I'm going to log, here's the base. What is base? Base is 8. 8. And what's the result? Was 4.5. And outcome of log is exponent, which is x. Okay, so this is, well, they're looking for this right here. Module 8. Okay. 19 says find the domain of log function. Well, what I have is g of x equals 7 minus, oops, sorry. I actually have 6. Well, not that it matters for this problem, but base 2 x over 7 minus 3. So this is asking to find domain. When we find domain of log function, we know that inside of log cannot be 0 nor negative. So this has to be greater than 0. Not greater or equal, just greater than 0. So then we have to see when is x over 7 minus 3 greater than 0. X over 7 greater than plus 3. X greater than 21. Right? So when x is greater than 21, that's the domain. Will not give us negative or 0 in the inside of log function. So domain is 21 comma infinity. Here, make sure exclude 21. Because if you plug 21, it will give us 0 inside, right? So that's the domain. And this one is also from module 8. Module 8. Okay. So number 20, write the log, let me see, log of a x minus log a y plus 6 log a z in condensed form. Single log result expression. Okay. So here, first we need to write this as exponent first. Like this. Then we can combine 2 at a time. This is log a. We combine to single log. Now subtraction means division within the inputs, like this. Now addition between same base log is multiplication within the inputs. So we have x times z6 over y. Remember, we start with 3 log expression. Now we have 1 log expression, right? So that's the main purpose of this problem, to condense it or write in single log expression. This is from module, I keep misspelling it, module, I think it should be module 8. Yeah, module 8 or 9, but I think it's module 8. all log exponential from module 8 and 9. Right? And 21 is going reverse as number 20, where what we do is we have log base 2 of x9 x minus 4. And it tells us that x is greater than 4 because otherwise we have indeterminate form within the log. So first, since it's division, we can separate into x9 minus log base 2 x minus 4. Now for here we can bring this 9 to the front. We get 9 times log 2 x9 minus log 2 x minus 4 is the final form. So here we're going reverse, as in we start with 1 and we expand it using separate log. Okay. Okay. Also from module 9. Module 9. Oops, sorry, module 8, I mean. Okay, so let's look at 22. 22 says solve the following log equation. So what I have is 6 log base 2x equals negative log 264. So here, because if there was no negative here, we could have just said inside equal to each other. Okay. Well, since you can't, we just have to have all the logs in the one side. So first I'm gonna write this as log 2 x to the 6th, because I'm bringing 6 right here, plus log base 2 64 equal 0. Now I can combine this to one log, right? Log base 2 64 times x to the 6 equal 0. Okay. Now we can rewrite this in exponential form. 2 to the 0 power is 1. Well, so let's write 2 to the 0 equals 64 times x to the 6. This is 1, so let's divide by 64 both sides. Again, this is the same as 1. 64 equals x to the 6. Okay. Let me see if I made any error. Okay, I don't think so. Okay. Okay, so then what number power to 6 power is 64, 1 over 64? Right, so here we can think as, well, we know that 64 is same as 2 to the, so here sometimes we have to try some of them. We know that 2 to the 4th is 16, 2 to the 5 is 32, and 2 to the 6 is 64. So it's the same as 2 to the 6 equals x to the 6th power. So then we know that half to the 6th power is same as 1 over 6 over 2 to the 6th power, which is 1 over 2 to the 6. Oops. So half is a solution, well, potential solution, but then we have to see if we can plug half here and only here, and we can't, since it will give us positive inside the log. So our solution, final answer, is just half. And this is from module 9. Module 9. Okay, so 23 is ln x plus ln x plus 10 equals 4. So here let's combine these first. I have ln of x squared plus 10x, I multiply that inside, equals 4. Then here again, this is same as log base e x squared plus 10x equals 4. So rewrite in exponential form with x squared plus 10x equals e to the 4. Okay. So rewrite it. Subtract e to the 4 both sides. Now, e to the 4 is a number, so we treat it like a number. So here we can use quadratic formula. X equals minus b. So here c is e to the 4. Right, so just plug the numbers, negative b, negative 10 plus minus b squared, which is 100, minus 4 times a is 1, c is e to the 4, over a is 1, so 2. Okay, so we can simplify furthermore here. So we can factor 4 inside inside a square root. And we'll see why we're doing this. So then here we can factor this 4 outside of square root. Since it's 4, square root of 4, we can make it positive 2 outside, like this. 2. And we can simplify, right? Then we get negative 5 plus minus square root of 25 minus e to the 4. So we have 2 possible candidates for solution. Well, both could be solution, none of them, or one of them. Like this, oops. Like this. Okay. Oops, I made an error here. I want to write plus minus 4ac, so this should be actually plus all the way here, right? Since it will be negative 4ac, it will be this times negative 4, which gives us positive 4e. Sorry about that. So here we go. Okay, so we have these 2 possible answers. So we have to see if I can plug both here and here, right? So that means we have to know if any of these will give us negative either here, either here or here. Okay. So here we have to do some analysis. Here we have negative 5, and we're adding a number that is bigger than 5 because square 25 is 5, but we're adding a number, right? So this value right here is bigger than positive 5. So this is a positive number, whatever that is exactly, right? Without a calculator, we will not know. Okay. Here, on the other hand, we're actually subtracting a number, right? Negative 5 subtract, and this is a square root always give us a positive, right? So we're subtracting a positive number from negative 5 must give us negative number. So because of that, this is not a solution. So only this is a solution. Okay, so that's very important here. Because in log, where we always have to positive number within, right? So here, because of this x, we cannot plug negative number here. Okay, so this is the only solution. So you will only write this, right, as a solution set. Okay. Okay. And part B says, what is the decimal expression, decimal approximation of this? This answer. But I don't. So again, you won't be able to you will not be need to do this, right, for the quiz. But the reason why this is here to show that this actually give you a positive number, right? Again, without a calculator, we cannot find the approximation, right? But you can just try to Google this number, and it will give you a positive 3.922. Okay, so again, 23 second part, the decimal approximation. Again, as you can see, that's not really integral part of solving any of this problem, right? It's just different answer form. So as long as you're able to come up with this, you should be okay. But the decimal answer, this is approximately 3.922. Okay. So 24, what let me write here? Module 20, oh, not 20. Module 9 again. So 24 and 25, we did a very identical problem. 24 is very similar to number 1. This is from module 2. Okay, unit circle. Okay, so it's just a very same problem, same type of problem from first problem I did in this video. And also you can get the unit circle idea from module 2 as well. Okay. 25 as well. 25 is again just drawing a triangle, right? Also module 2. And I believe that was a second problem I did in this video. It was very identical to 25. Okay. Okay. So then here's 26. Okay. So 26 says match each given function to one of the graphs. Okay. So here, well, let's look at one at a time. Y equals -2 cosine half of x. Okay. Well, so let's sketch one at a time. This one, first find the period is 2. Oops, sorry. Actually, let's find the amplitude first. Amplitude is absolute value, which is 2. So it will be high is 2, and lowest point will be -2. It's also -1 here, right? Well, negative multiply. So also, if the generic shape was this, it also reflect over x-axis. So it'll be like this. Okay. So make sure to pay attention to the reflection. Okay. So then what we have to pay attention next is the period in this case, right? So there's no other transformation, that there's no midline changing. So in order to find the period, was 2 pi over BA, right? So period is 2 pi over B. So in this case, B is half, gives us 4 pi. So for this one, oops, sorry. Zero to regularly 2 pi, but it's 4 pi now. So the graph will seem more stretched compared to regular cosine. So it's 4 pi. And these are the 5 points, but it's reflected. So actually, let me do it. This one will be right here. These are the 5 points. So graph will look like this. So this one, and you can find something that looks like this, in those given choices, right? So this is a generic shape. Okay, and do pay attention to the these numbers here, 4 pi, right? And this will be 2 pi. Okay, so that's a generic idea. And let me do a few more. I'm not going to do all of it, but let me pick something different. Okay, y equals 2 sine. Again, you might have different numbers, but this is a generic idea, right? You might have completely different choices and different graphs, because again, number on each problem for student to student is different, but the type is same. So same thing, amplitude here is 2. Period is 2 pi divided by pi over 2, which is 2 pi times 2 over pi, which is 4 now. So that means when we sketch this, it's 0 to 4 here. And we divide into 4 sections, right? We can do 1, 2, 3. Right. And sine graph has shape of usually this, right? Like this. But since amplitude is 2, it's 2 and negative 2. And we follow those primary points, these. And it has this shape like this. Right. So what you have to pay attention when you do this problem is first amplitude, well the order, but amplitude, make sure you pay attention to amplitude, and the period. Right. So once you recognize those two, then generic shape of sine function, you should be able to identify which graph is corresponding to this function right here. Okay. Yeah, let's do one more. Let me do. So this one's not on my option, but I'm just going to do it just for practice. Again, the concept is all same. I'm going to do negative 5 sine of 2x. So amplitude is absolute value of 5. Negative 5 is 5. But again, negative 1 means it flips. So this is generic graph of sine, but negative means that graph will now look this shape because it reflects over x-axis. And period is 2 pi over, right? Yeah, 2 pi over 2x, well 2 gives me pi. So for this graph, we have 0 to pi. Here's pi over 2. Remember, generic sine graph will be using these 5 points, but because it is flipped, will reflect across x-axis with this one, this one, this one, this one, and this one. So it has this shape right here. And also, because amplitude, this is 5 and -5. So when you do this problem, you do have to again pass into x-axis and y-axis. What are the numbers they're using, and use as you can see, it's either -2 to +2 or -5 to +5 on y-axis. And for x-axis, it's different, depends on the period of the problem, right? Yeah, so for this one, I do suggest you graph it on your own first, like I did here. Okay, and try to match them. Okay. Okay. And okay, this is from, okay, let me make sure what module this was. This was module 3B. Module 3B, graph of trig function. Okay, then let's look at 27. Solve the equation between 0 and 2 pi. And the trig equation I have is 6 cosine theta minus 3 equals 0. So we want to isolate the trig expression on one side if possible. I get it, cosine theta equals half. Then again, I know we did a similar problem earlier. So then what angle measure between 0 and 2 pi will give me cosine of that angle, half. We'll go back to unit circle, will be pi over 3 and 5 pi over 3. Okay. So 28, well, sorry, this is module, let me see, 6B. 28, establish the identity. Cosecant theta plus 1, cosecant theta minus 1 equals cotangent squared theta. Okay, so multiply. The first part says multiply and write the left side expression as difference of squares. So that means this part right here, we multiply. So, I mean, you can just do this and simplify, but this again is the same idea of a plus b times a minus b simplifies to a squared minus b squared. So here, that's how we get c cosecant theta minus 1. Cosecant squared minus 1. And this equals cotangent square theta by the Pythagorean identity, which is option B. Okay. Okay. So 29, we just did this. Same problem, right? 29 is from module 10. Okay, module 10. I'm afraid my pen's are gonna out of battery. You can miss it. And 30 is partial fraction decomposition. Is from also module 10. Okay, so and then, you may have noticed module 10 materials is more just skill-driven practice, right? And I did a lot of different problems in the lesson video as well, or the second part of the videos, me going over the problems. So make sure